Lesson 1, Triangle Theorems and Congruents. Learning target, I can classify triangles and apply properties and theorems of triangles. One note before I get started, this video is going to be a little bit longer. I do apologize in advance. Bear with me. First off, please access your resource sheet. You can get that in your resource folder on Schoology. Make sure you access that. But we are going to be working with triangles this unit. So a triangle is a polygon with 3 sides. So a polygon has straight sides and vertices, so the points where they touch. And when we name a triangle, we just name it by its 3 vertices. So we have triangle symbol, ABC. So we have vertice A, B, and C. We could also name it BAC, CAB. Doesn't matter. I like to go in alphabetical order, but you can rearrange the letters in any order. And we can classify triangles. So we can classify them by sides. So scalene, no congruent sides. Isosceles, 2 congruent sides. Equilateral, 3 congruent sides. And we can classify by angles. So acute, 3 acute angles. So none of them are bigger than 90 degrees. Right angle means you have 1 right angle or 1 90-degree angle. Obtuse means you have 1 obtuse angle, so 1 angle that is greater than 90 degrees. And then equiangular means all 3 angles are congruent, so they would all be 60 degrees. And that is a consequence of being equilateral. All equilateral triangles are equiangular. So let's practice this. We've got classify each triangle by angles and sides. So the first one, if we look at our angles, all of our angles are below 90 degrees, which makes it an acute triangle. And then if we look at the sides, none of the sides are the same measure, so that makes it scalene. So an acute scalene triangle. I want you to try this one on your own. Put your answer in Edpuzzle and see if you are correct. Types of angles. So when the sides of a polygon are extended, other angles are formed. The original angles are interior angles. The angles that form linear pairs with the interior angles are exterior angles. So we have the normal angles on the inside, but if we extended the sides, we get these exterior angles. So here's an exterior angle. This would be an interior angle, and they make that linear pair because they're on the same line. So remember, linear pairs means that they are supplementary or add to 180. We also have our triangle sum theorem. The sum of the measures of the interior angles of a triangle is 180. So if we were to add up the measure of angle A, B, and C, they would equal 180. Then we have a corollary, which just means it stems from the triangle sum theorem because it's corollary to the triangle sum theorem. So it's like a consequence of that theorem. Is that the acute angles of a right triangle are complementary. So if we have a right triangle, we already know that one of our angles is 90 degrees, meaning 180 minus 90 is 90. So the other 2 angles have to sum to 90 degrees, which is what complementary means. So we're going to apply that theorem here. We have find the measures of the acute angles of the right triangle in the diagram. So here's a right triangle. We know by this corollary that the other 2 angles are going to sum to 90 degrees. So we can set up an equation of 2x plus x minus 6 equals 90 degrees. I'd like you to get a little solving equation practice and solve for x. What does x equal? Test that out in Edpuzzle, and then we'll continue. All right, you should have gotten that x equals 32. Now we're not done because the question asks us to find the measures of the acute angles. So we want to know what's the measure of this angle and what's the measure of this angle. So we can plug 32 in for x here. 2 times 32 is 64. So this angle would be 64 degrees. And plug 32 in for x here. 32 minus 6 is 26 degrees. You can always check, make sure 64 plus 26 is 90. And it is. So check, we did the problem correct. Couple more theorems for you guys. We have exterior angle theorem. So remember, exterior is on the outside. The measure of an exterior angle of the triangle, so if we look over at our picture, it'd be angle 1. That's an exterior angle. Is equal to the sum of the measures of the two non-adjacent interior angles. So non-adjacent means just the angles that it doesn't touch. Interior, so get a different color. We have 3 interior angles. We have angle C, angle A, and angle B. Well, angle 1 touches angle C, and you can see they make a linear pair, so those would sum to 180. So then we would know that angle 1 is equal to the sum of angles A and B, because those are also going to make 180 with angle C. So that's also a consequence of that triangle angle sum theorem and the fact that exterior angles are linear pairs. And then we have our third angles theorem. So if 2 angles of one triangle are congruent to 2 angles of another triangle, then the third angles are also congruent, which should make sense because we have 2 congruent angles. This one, since they have to sum to 180, would also be congruent. All right, so we are going to apply that exterior angles theorem that we talked about. So we want to find the measure of angle JKM. Well, here's JKM. So we want to know, what does 2x minus 5 equal? Measure of angle JKM equals 2x minus 5. So we're going to have to solve for x. So to solve for x, we're going to use that exterior angles theorem, which tells us 2x minus 5 equals the sum of the other 2 interior angles it doesn't touch. So it touches this one. It doesn't touch x and 70. So the sum of x and 70. Solve that equation. We can subtract x on both sides and add 5 to both sides. 2x minus x is x. That cancels. 70 plus 5 is 75. We know x equals 75. Now we just need to plug that in here. 2 times 75 minus 5 is 150, take away 5, which is 145 degrees. So that would be the measure of angle JKM. All right, last little piece here. We have congruent figures. So all the parts of one figure are congruent to corresponding parts of another figure. That makes figures congruent. So congruent polygons, we're going to be working with triangles specifically, meaning the corresponding sides and corresponding angles are congruent. So all 3 sides have to be the same and all 3 angles have to be congruent to each other. So you have examples of congruent and not congruent, what that looks like. Now when we work with congruent figures, we're going to have to write a congruence statement. So a congruent statement just compares 2 triangles to each other, but you have to write them in the way that they correspond. So if you look up at our picture, angle B is congruent to angle G. So when I write this triangle, I would start with, if I started with B, when I write this triangle, I'd have to start with G. And then angle C is congruent to angle H. So then if I'm going to follow that path from B to C, I'd have to go from G to H. And then I'm going to go up to angle D, which is congruent to angle I. So if I put D after C, then I'd have to put I after H. Then I could say that those 2 triangles are congruent because they have all 3 sides congruent BC is congruent to GH, DC is congruent to IH, and DB is congruent to IG, and all three angles were congruent to the other angle. So you have to just write it in the correct order, hopefully that makes sense. Okay, I'm gonna end the video there. Go ahead and move into your practice, and if this congruency piece is just the introduction, and we will talk more about that in lessons 2, 3, and 4. So that's just your intro. Go ahead and move into your practice.